Okay, welcome back, friends, for another week of awesome Haskell hacking. Sort of, maybe. We're going to be working again on a small little project for funsies. We are implementing a game I'm calling Lambda Trek, which is, I guess, kind of based off of like this old game I used to play when I was a youngin' called Super Trek. Just kind of like this, based off an earlier one that was basically Trek. And people have made so many clones of this game, so many variations of it, that it's pretty fun to try and implement your own. So it's a turn-based game. We're building it in using a terminal UI library called Brick in Haskell. And yeah, we're going to see where it takes us and that kind of stuff. So let's see what we got. I think what we have so far is pretty bare bones. Let me bring up a little window to show it. So because it's built in a terminal UI, obviously we've got to run it inside of a terminal. I'd like to build this project in such a way that we could port it to a graphical environment later on, and maybe like a virtual terminal in a graphical environment, something like that. Just so that we can like port it to other platforms pretty easily and that kind of thing. You see that sort of stuff happen in roguelikes a lot, in a game called like Sanctuary RPG, that sort of thing, where it looks like a terminal, but it's not. It's more of like a graphical application layered on to emulate a terminal. But be that as it may, we can think about that far into the future. Brick is like super easy to get started with, which is why we like it for prototyping and stuff. This is gonna be good. So this is our UI right now. We're kind of like blocking things out. This is gonna be the left sections where we're gonna show mainly like the map widgets and stuff. Maybe like an action log or something below it. And this right-hand section here, we already got it split up into kind of like an info panel. I think this is going to be up here on the right-hand side. And then our little command input box will be down here. So if we want to like, where the user's going to type in their commands, because it's going to be a command-based, kind of turn-based game, they're going to input that there. And if there's any like errors with their command, we'll figure out a way to display that properly so it looks nice and easy to use and fun, most importantly. Right, so let's see. I'll just pop out my chat here, make sure that I can see y'all chatting with me as we go along. So if this is your first time tuning in, welcome. Thanks for stopping by. It's always nice to see fresh faces on the stream. This is where I do a lot of functional programming, and we do like actual projects. We build libraries and games and applications of all kinds and sorts, just to give you a taste of what it's like to work in a functional programming language on like real sized-ish projects. Because at the end of the day, it is just like programming in a lot of different languages, just a little bit different, but like it's still programming, it's still making things. And that stuff is still the same, so that's what we do here. Anyway, moving on. Let's open up our project code. We'll get started. How? Have you ever any questions about what's going on the stream? About the code, about the game, or whatever we're working on? Or just been like, hey, check out this thing. Feel free to interrupt and just chat at me. Tell me what's going on. It's all good. Okay, so we're at Lambda Trek source. Lambda Trek is our main entry point for our applications library. /module/ everything. We split everything out into the UI. Today, I think... Oh, we started doing command parsing. right? And I think we are pretty close to finishing, at least the basic couple of commands we want to implement first. Mainly I'm going to do, we'll probably do engine move first, but there's jump move, engine move. We have a parser. Under command, parse. And we can run our command parser, which is super good. On command parser, like this, we give it a string. Our string is like move 2323, say. Super. And if we want to do jump, and then we have to give it in quadrant coordinates or sector coordinates. AI. Cool. So our command parser works, and we'll be able to tie this into our main kind of game loop at some point. Maybe the next logical step is to actually do our input form. And get kind of the structure, the stick of that going. And then when the user inputs the engine move command, we'll just update the left panel. We'll just replace the text there with the name of the command that we did and the parameters we passed in. And that'll be like a nice small little chunk of work. Then it gets to the next step that we need to get things to. Okay, so let's do that. How do we do forms and like input with brick? That's going to be my next question. Guide. Try that first. Okay, attribute maps and all that stuff is great. We're going to do not viewports. Input forms. Here we go. It's possible to construct interfaces with editors and other interactive inputs manually. This process is somewhat tedious. All the event dispatching has to be written by hand. A focus ring or other construct needs to be managed, and most of the rendering code needs to be written. It makes it difficult to some common patterns. Yes, it does. The brick.forms module provides a high-level API to automate all of the above work. Great. So let's use a data type we want to use as the basis for an input interface. Okay, so our interface is going to be pretty easy. Want to build an input form for the above data. We might want to use an editor to allow the user to enter a name and an age. Okay, we need to ensure that user's input for the age is a valid integer. For the ride's bike, we want a checkbox style input, and for handed, we might want a radio button. Password, we definitely like a password input box that conceals the input. Right, we just want a regular text box, but hopefully this will get to that. So muck form, user info to form user info e name. There, call new form with a list, I guess, of like form widgets. Edit text field, that's probably going to be ours. That's good. Okay. Name just one. So a form is represented using a form sen value. That's parameterized by some types. That's these little type parameters here. They're like arguments to our type. Or values to our type. Something like that. S, the type of form state managed by the form. Guys, for us this is going to be a simple text thing, I think. E, event type of the application. Okay, we should probably set up an app then, I guess. Because we'll need to know what that is. And then N, the resource name of the application. Oh, we're gonna need to use micro lenses and stuff too? Okay, cool. Okay, so first things first, let's get off of simple app then. And get our own proper app type set up. That is up here. It's handling apps, running an application. Okay, there we go. Okay, so we create an app, our initial state, our final state, we can get it by calling default main with our app and our initial state, and we can use the final state and exit or whatever we want to do after that. Okay. So let's define our app then. Lambda trek. Let's do it here. Lambda trek app. Where? We'll import brick dot main. So we'll call it, not app, we'll call it Lambda trek app. App is parameterized on a couple of things, SE and N, right? Same sort of thing. State, application state. All right, the event type. We're using custom application events. And resource name type. During application execution, we sometimes need a way to refer to rendering state. Okay. Okay, resource names. Okay, Lambda trek app. Okay, so we need Lambda trek state. Or let's just call it game state. We don't have any game state yet. Although, if we're going to make it change the text of what to display in the left panel, maybe we should make that part of our game state for now. So let's do that. Just make this a new type. Game state. Display message. And that could just be... let's just say string for now. We might really want text, but we're just trying to get things up and going here. Okay, so that'll be game state then. We still have to provide a couple more things. Some kind of event type. And some kind of resource name. Okay, and this will be app draw. I'm just going to copy some of this. And replace all of this. With this. Put some holes in there. Okay, Cool. Okay, so draw has to be a function s to list of widget n. And we'll call that render. Yeah, a function render. And what else? We need a choose cursor. And I'll just continue on. Yeah, I'll just call this handle event. Start event and counter map. Yeah, that's what I'm gonna call them. Right. So we need all of these in scope. We'll put rendering in a sister module or a sibling module. All like that, and then we'll import it here. Here. Okay, for some reason it thinks render should be that, but I want it to show the type barrier. Haskell process restart, maybe. If I got my builder down here going, it'll point it out. Back build, fast, file watch. Oh, maybe it's getting stuck on the same things as the builder is. Choose cursor. We'll put it in there. And start event. And adder map. Just get the type squared up. Then we can start filling things in. Let's import that name. Oh, okay. There's one already defined, so we're gonna have to rename ours. We'll call it Lambda adder map. Okay, so start event needs to be comes from. What? It probably comes from brick.event, right? No, it doesn't. Let's see. Let's go to the brick attics. Event M. Brick.types. Okay. Import brick.types. Okay, I have to rename it to Lambda render. And let's go back over to render, rename it to Lambda render, and we're good to go. And this doesn't have the right type. Game state to list of widget R. Empty widget. Brick.types. Okay. Import brick.types. Game state. Because we're gonna need a sibling module for this as well. Lambda trek state where, and we'll just have game state here. That's so we avoid any circular import issues. Since the render is going to be importing the state and the app module is going to be importing render, if render tried to import from state, then you'd get a circle in the dependency graph, and that'd be no good. You always want your dependency graphs to be like a tree, no cycles. Import Lambda trek. State. Okay, now that should be good. What's the next problem? Handle event. It needs a type, the proper type. There we go. Okay, well, it's gonna not restart until I get the proper types here. And and then we need game state list of cursor location, something, something. Let's check that. List of cursor location N, returning Navy location. Okay, so that all compiled. I mean, we haven't defined anything yet, but I just got the types lined up. Okay, bye. I'm just gonna rename these to be all consistent and the same. Replace string, choose cursor with Lambda. Choose cursor. Lambda handle event. Lambda start event.
Come to the place where we joke about the idea of the devil, with the horns and the tail and all that. But that is Satan's lie to distract us from the reality of
Lambda start event.
He's no mask in a Halloween store. He's not what you see in movies. He is an active.
Hey, Damien Frau, welcome back. Nice to see you again. I am working on the Star Trek game again today.
He lives through us.
We are continuing on. We're getting the core of the like kind of app state set up so that we can hook up the input form for the command input processing. We did the parsing last week for the command parsing, and so we're going to get that widget going today. And then, if we have enough time, maybe we'll start working on the simulation and getting that working, so that we can actually interpret those commands and update the simulation state. That'd be nice. See how far we get today. Okay, so this is like the basic structure of our app. Now we have an app we've built. It does nothing. It just does undefined, but we should be able to like hook it up something. So our main run is in Lambda track up here. We should be able to import Lambda track dot app. This might completely break everything. That's okay. We'll get it working back to the way it was, just with this new app stuff. Ooh. What is this Damien from? I want to check it out. Can I use? Ah, very cool. Language extensions. I like it. Yeah, we're very lucky to have Brick. It makes these TUIs like super easy to make. Right, 9.2. That's great. That's super sweet, dude. Friend. I love it. That's really sick. Yeah, you should totally do a Brick one. Super sweet. Okay. Yeah, so we have to set up our initial state. That's the next part of creating our app. So we already have our app imported. We can initial state. It's our message. And then, what do? We call default main with app and initial state. And all right, we're missing some imports, of course. That takes care of that one. Default main. Oh, app isn't in scope. What did we call it again? Initial... no. We just don't care about the return results. Let's do that for now. Oh, okay, fine. Make me look it up again. Merp, merp, merp. Lambda Trek app, that's what we called it. What's the problem here? Let an ambiguous type variable arising from the use of default main. Okay, we can't get the constraint ORed and 0 from being satisfied. What needs to be ORed? Maybe the game state? I bet that's probably what it is. No? Not that. Okay, okay. think we're gonna have to look in their repo and figure out from an example, maybe. What is requiring this ordness? Well, they do custom main here. I want to see default main. Let's search custom default main. Okay, dialogue demo seems to use it. Choice, red, blue, or green. Name, red button, blue button, green button. Maybe this event stuff? Because the events... Let's see, this event M name. This name here has ord. We haven't defined that in our handle event. Okay. No instance for ord R. That's weird. We should probably look at resource names then and figure out what that is so that we can define this properly. Seems a little bit hacky. Probably because it is. Resource names. That resource names are used to describe cursor locations. Okay. Resource names are also used to name other kinds of resources. Okay. Viewports, rendering extents, mouse events. Assigning names to these resource types allows us to distinguish between events based on the part of the interface to which an event is related. Your application must provide some type of name. For simple applications that don't make use of resource names, you may use unit. Okay. So I guess this kind of means, like in this, say, UI demo here, you can put your cursor in different places in the UI. And that's needed to figure out where the cursor location is in from the screen space, I guess, the terminal screen space to the widget or something like this. That seems like maybe what that's for. We might need that for this game so that, like, we can But probably not, no. Like, I think the most part, we're just going to be focused on the... There might be like some global hotkeys, but the commands and stuff, the command input is basically going to be the main interface for the user. Yeah, so anyways, this just means that we can use unit, I guess, for that instead of R. In fact, let's just put both instances of that in our type signature here. Bang. Fix that. And then what? Okay, yeah, we got this up here too. Okay, and Lambda UID is redundant. Okay, so now we compile again, we're good. But if we try and run this, it's gonna break. Probably, like 100% probably gonna break. So, it wouldn't work. Alright, we're gonna get a seg fault because it's gonna like try and call into things with undefined and it's just not gonna be happy. So we need to then update our rendering. That at least should make it work again. So let's get rid of this redundant import here. Go over to render. Okay, then we get game state to UI. And UI is a widget, unit. So we can almost ignore the game state here and just return UI. This is the problem with this. Yep, it's got to be units. Cool. And hopefully this works now. No, still doesn't work. Okay. What else do we need at a minimum? Probably handle event. Adder map, probably? Is there like a default adder map? No. Well, in order to get the same behavior, I'd like to have the same attribute map we had before when we used the simple UI. So let's look that up quickly. Simple main. How does simple main work? Is default main a simple app W? Simple app W, adder map, like this. Def adder, we need a definition for that. Def adder. Graphics.vdy.attributes. Good times. Good times. We ignore that. Okay. Okay, so we need VTY to be exposed in order to import it. Let's update our package.yaml. Okay. So compiles now. Does it actually work now? Nope, not yet. Still need more. Change that. Does it work yet? Nope, still hitting undefined. Let's just do, can we do pure unit there too? Do nothing? Okay. Now does it work? There we go. We're back. Okay, great. So you have to implement everything basically to get it back. But we have no input handling here now at this point, so we have to like bring back input handling to be able to quit. Let's steal from simple app, handle event, resize or quit. Okay. Let's do that. Yeah, EV resize probably comes from V2I. Break.types.internal. What are we supposed to use? Okay, maybe we should do it more like that. Use the actual API. Why? VTY event. Something is something. I don't even know what this is. Okay, there we go. V.resize. What do they import V as? Graphics.vty as V. Okay. V.ev resize. Oh, it's 2 arguments, doesn't it? Kind of like our simple app. Resize or quit. Oh, quit was halt. Basically any event. Do nothing. And halt. Halt the event loop and return the specified application state as the final state value. Next action equals halt. Something similar to this. Our game state's gonna be a little bit different. Oh, Brick.main already has a halt defined. We don't have to worry about that. Okay, we don't have to worry about this for now. Okay, so hopefully we get the behavior we had before now. Let's get my file build watcher going here. I just accidentally closed the terminal window that I wanted to keep open. Oopsie doopsie. No worries. Let's go to Lambda track. And now I should be able to... I'm not getting able to quit out yet. Nothing. Okay, so that's not how we should handle quitting, apparently, when we build our own app. Oh, okay, this seems like we should probably actually do the pattern match and explicitly get out the key. Probably should do case EV of. V, EV, resize. V.EV key. V.ESC. It's probably like a list of modifiers, I guess. Alt. State. Graphics.vty as V. Yeah, that's what we want. Okay, escape. Sorry, I'm missing a verb. Just nothing. Okay, we can quit out. That's good. Okay. So we have all the behavior we had before. We just have more places now we can customize things and yada yada yada. Okay. So let's just review the code we have so far. We added app rendering state. App, that's our main like kind of app structure. Render just returns the UI from UI. Suppose that we could probably, like, depending on the game state, render different UIs, which is probably why we're going to keep that there. And there's a game state. Okay. Create a commit for this. Add app and game state. Basic brick application structure. And calls custom main. Or no, default main. Sweet. And now we can add our form widget. Okay, so the state parameter here passed to app is a form user info e name. Okay, name is either name field, age field, bike field, handed field. So this is where you can tell where the cursor is, like which widget's on. The name field, the age field, the bike field, right? That's what that is all about. All about. User info here is the state to the form. Here. Interesting. Okay, and then we return a form here, which we call, labels and all this sort of stuff. And we call new form with our list of widgets we want to show. Render the form. Interesting. So this becomes our our state, our application state, at least in this instance. What if we don't want it to be form? I don't want to do like the game state as like the whole state as a form. That doesn't seem like something we want to do. But I guess that's like the way to do it, I suppose. The other thing we could do, I was thinking like maybe we could do it like a rogue-like kind of control scheme, but I think the command interface is still the way to go for this, because like that's just the way Super Truck used to be. And it makes it a little bit more interesting because, like, in the original game, I think it was firing the photon torpedoes, so to speak. Firing torpedoes, you gave it in polar coordinates. And so it would kind of try, it'd be like, 45 degrees. You know, and it would just be like, pew. And kind of like shoot the torpedo out along that direction, along the grid, along that line. So it made it sometimes a little bit tricky knowing like the rough polar coordinates and how they move across the grid to get it to hit the target you want it to hit. But yeah, so we're still going to need some kind of like input for that. Like doing that with just plain key matching is not going to be the way to go. Okay, well, I guess that means we do have to do it this way with like a form thing. And that has to be our whole state. We can't just have like a widget. Alright, well. Not the dialogue demo. We're gonna go with the form. Programs. What other demos they got here? Visibility, custom keys, text wrap, tail, table list, table, Padding mouse. Form fill. Edit. Cropping, cache, border, adder. Yeah. All right. Let's just go with it. It's what it wants us to do. We're also going to need lenses micro, it looks like. So we'll import that here. No, under state. Let's go to state. We're going to need and label the language extension, template Haskell. Bang. This ain't right. Oh, that's right. No, we just have to add it to our package, I bet. Micro lens. Microlens dash th. And there we go. I got lenses for game state. Cool. Okay, so let's cheat. Let's go to the app. Let's go to you. What do we gotta do next here? Gotta render the form. We got the state already. We gotta write our muck form, I guess. Okay, so let's put our muck form, I guess, in UI. Game state unit. So list of widget unit. Okay, okay. Actually, no, this could work. This could work. Okay, okay. So this is just a list of, I guess these must make widgets. Let's try this. New form. And we're gonna have, should we put a label on it? Maybe just for you, just to check it out. And this at equals sign. At equals. Edit text field. Okay, it is going to need a proper name, not just unit for this, I suppose. And a lens. Okay. So. Name. We'll have command field. That's it. Command field. Or, sorry, name. What's the problem here? Okay, form and game state aren't in scope. Import lambda trek.state. I know how to do that one. And import break.forms. I meant forms. Okay, and this should be from state, our lens message. Probably make it command. And where does label come from? Oh, I see. This is defined here. Okay, let's copy that. Name field, and then just one. And then new form, where's that come from? Is that defined in here? Oh, that's imported from bricked up forms. Okay, that's not in scope. That would make that not a scope. Because of lenses. And what's our next build filter here? Expected form, game state, name, widget of name. We got actual. Oh, okay. That's interesting. Oh, okay. Yeah, we got the type messed up here. This should be game states. To form game state name. Okay, and then this just isn't in scope. That's probably because maybe it's exported as game state command by make lenses. There we go. Could match car with text. Probably because edit text field wants a text, not a string, so we're probably going to need to just go ahead and do the text thing. Honestly, you should probably just like import text from pretty much every Haskell project by default. The game state. We gotta import data.text. Text. Yeah, okay. And then we need some instances for our name class. And we need some overloaded strings. Yeah, just like that. Now we should compile again. There we are. Okay, so we have muck form. What is this complaining about? It wants us to take away the braces. That's it. Okay. So now that we have the form, and we just actually, how do we use this now? How do we render it? So we have a draw function that takes our state to the list of widgets. How do we render a form like we do, okay, with everything else? Okay. So we should be able to incorporate this. I think this means we can incorporate this into our current UI. We just have to update UI to take a form as input, F. I call render form on it to render the actual widget, or widgets. Okay. So we should be able to change this to form game state. Name. It's just a, it's, yeah. I think I understand why it's structured this way, now that I think about it and see it, but it's a bit, yeah, it's just something you gotta get used to, I guess. So where we had, let's see, our command, what we called the command palette, this is where we're actually going to render the widget, the form widget. There's center, but instead of stir command, we're going to render form F. Right. Not quite. Okay, so render form here. Oh, widget can't return unit here. It's going to be name. Okay. And this has to be named. They all have to be named now. Yeah? Okay. Command palette takes an argument now. It needs the F to be passed down to it. Okay. And we still got... Yep. Some type errors there. So let's go fix those. In render. And this is no longer just game state, it's got to be form game state e name. And that needs brick.forms. Okay, which is probably going to propagate another error up to our app itself. Okay, so I think we're going to need a different place for name and a sibling module. I think. Let's just try it here, though. Maybe not, because UI probably doesn't import app, so it might be fine. Event M now does name, and that'll be the same over here. This will no longer be just game state. This will be form game state name. It's almost like it wants to be like a transformer in a way. It feels very much like that. Okay, so choose cursors type is probably going to change. Because you can click on things and then figure out which widget was clicked on using that. Handle event. Brick event name. Let's see, we expected brick event name E. The state. Here. Form. Game state. E name.
I never knew anything like this in the whole of my life.
Header map.
Is a glass of water, colorless.
Same thing. Okay.
It contains
I think I want to type alias for that because it's getting annoying. Okay. Now we should be back into compiling land? Almost. I just have to update our entry point to set up our initial state. Okay, so we use our muck function that we wrote, muck form, I think. Yeah, to construct our state. Import lambda trek .ui, muck form, game state hello world. Okay, we're back to compiling. We're a success. See what we got. Okay. This is what we got so far. It does render something different. Not sure what we can do with it yet. Doesn't look like a text input field at the moment. Well, that's something. Okay, so what do we need to make this work?
Everything is in color, and I can feel the air. I can see it. I can see all the molecules. Can't you see it? See it?
So edit text field. Let's look at this here. App choose cursor. Focus ring cursor form focus. Oh, interesting. Okay, so we track. So in our handle event, we can get the form focus. And then we handle form events separately from the other ones. Okay. Okay.
Beauty in my life. It's like a curtain, a spider web. It passed right through.
Okay. Okay, so that means we so we change our initial game state. Right now, I think it's that string in Lambda track. It's not rendering all of the string though. It's just rendering hello. Or no, world in this case. Interesting. Okay, so it's never getting enough room to render the whole thing, which is kind of not what we want. Let's see if we can pretty that up a little bit. I think all of this stuff might not be what we want. Okay, so the label thing is like composing a couple of horizontal widgets. Let's take out the H limit. That's a little better. quite what I want. How do we get, like, let's see, H limit percent. And still centered would be nice. So that looks a little better. Okay, and let's not do any padding on the bottom. There we go. Good. Now we want to be able to take input to it.
We woke up on the floor, our bodies intertwined. You're doing that thing you do. On your mind.
Form.
Restlessness and worries for a future that's unknown.
The command input uses a brick form for the command input. There we go. Okay. So that means now that we need to be able to take input. I mean, I guess that means we need to like add focus to it somehow when we start the app, and then we have to handle form events. Form focus. Is that part of the state in this example? Name, age, address, rise by candidate, password. No. So I guess that's part of the library. Let's see. So F here, we bind that to getting from the state the form focus, current form focus. We pattern match on EV, the event, as usual, to handle resizing, the escape key, enter key. Otherwise, we handle the form event. And we get the form state again. And then we set the valid field. Oh, this is a validation example. If we wanted to do input validation from our parser, I suppose, we could be able to get this. Something like that. And let's handle form event defined here. Where is that defined? Handle form event. Oh, 124. Oh, so it's imported from brick.forms. Oh, okay. Handle form event. So maybe all we need to do is add that to app. Maybe here. Handle form event. EV. That's a v.event. Okay, this is slightly different. And they're not plot matching out the event like we are. So we'd have to do that here with VTY event. And here too. There we go. Builds, compiles, does it work? Hey! Ah, okay, cool. We got input going. Cool. We can press escape. Very good. Input handling. Okay, so that's sweet. Okay, so that handles the input. Now we need to handle when we press the enter key. We parse, and we get a command, and then we dispatch out to our game loop to do the turn handling and all that stuff. What we're going to do for now is... What are we going to do? We're going to update our game state. So command. And let's call this command input. And then command will be maybe not command. Yeah. Import lambda trick dot command. Yeah, it's no longer a new type, it's a data. We can't get ORD because command doesn't have an ORD instance, so let's add it. And quadrant core ORD doesn't have an ORD instance. That's in units. Easy enough to add. Add it there. Add it here. Happy little ORD instances. Okay, and then our form handling rightfully wants to be updated. So we can take command input. And our initialization. And that should compile again. So I add add command for game state. And there. Now we want to add on the track now app. So let's do a handler for VTY event v.ev key v.k enter. We want to do something here. What I want to do is update the game state here with our command. So I think I can do so F here. I think we've got a few micro lenses that we can use. And get this to get the game state. Maybe that's what we need. Let's call it. What is this? Okay, so F is the form game state E name. If I use gets form state, F becomes game state. Okay. And I can modify the game state a certain way. Okay, so this whole becomes form game state E name to form game state E name. Okay, what other lenses do we have to update the state of the form? That's what we need to figure out. Next. Forms, here. Update form state. Okay, update state contained in a form. This is what we want, I think. This updates all form fields to be consistent with a new form state. Where possible, this attempts to maintain other input states, such as text editor cursor position. Use carefully. Okay, so that takes an S. That's going to be our state. Update form state. Okay, so we don't want to modify. And I guess S is going to be the state we want to insert in there. Yeah, too few arguments. Oh, we do need the modifier. Wow. This. Too many arguments. Yes, okay. Skadoosh. Okay. So now this whole is just game state. So we can change S to be I want it to be Lenzy. It could be Lenzy. We could use just regular record syntax. Game state command. Okay. This needs maybe lambda check command command. Okay, so this is where we can, in order to fill in that hole, we can get a maybe lambda check command by running our parser. We'll do that this way here. Let's see him maybe command B, run command parser. And then we can do that with S of command input. No, we need import microlens. Import micro lens. 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 It's lens.micro. Okay, that's what I want. I probably meant hat dot. Okay, I need command input. That comes from lambda check. Sorry, game state command input. And then run command parser from lambda check. The command parser. Okay, what's the problem here? Couldn't find. Oh, parse, not parser. And we got some text conversion fun stuff, fun times, happy fun times. We will have to import data.text. It's t, and then we call t.pack. Unpack. And then we have our maybe command, fits right in our hole. Okay. Sweet. And now what I want to be able to do is render the command if there is one that was successfully parsed in our UI. Just to show that everything's like hooked up and working and all connected. So sim display. Let's do it in the sim display. So this is now going to take our form game state e name. And we're going to get out of the game state a current command. And that's going to be stir dot show of current command. I'll just give the inference a little help. Basic type applications. There, and then we have to pull in lambda track.command for the types. And then sim display needs rf. Okay, my inference approach didn't work with show there. Okay, that's fine. Okay, so what I need here, I think, is get form. No, get state. F. Oh, what did I do with... that works in event M, but it might not work for us here. What do we have? Okay, we can call form state on it to get it. That's what we want. That's the first part. And do game state command. Okay. Add all commands. Compiled. Blah. Good. Hello world. Let's do move 22, 22. We could just engine move 22, 22. Sweet. We should also do jump. A to I. And we get a jump move. So it's all hooked up. That's good. I like it. Also, when we press enter, I think we should probably empty out our command buffer to be ready for a new command. So we do that. Here. Game state command input equals empty string. We have to do overloaded strings. There. Okay, and our buffer empties out, ready for more input. Sweet. Press enter, nothing. Sick. Okay. Let's clean up the initial state in app. And then we can push this all up. Because I think we're a little over time this week. Let's go Lambda trick. Sweet. So when applied, this change will parse command input field. We can now parse user input into a command, adding the command to the game state. Currently render the current command in the left pane. Okay, I'm gonna see, let's rebase. We'll squash these up, reword this. We add the command input form widget, parse user input, and add the parsed command to the game state. Squash all those up. Cool. So, push that up. Alright. Thanks for tuning in and hanging out with me for a little bit. If you want to check out the code that we worked on today, you can find it on GitHub. I'm Agent Ultra, by the way, if you don't know. And this has been a Lambda Trek. Our new Super Trek variant built in Haskell using the wonderful Brick library for our UI. So you can check it out there, and you can follow along, start, whatever. Please give us some stars. Look, it's so lonely. It's only got 0. That's okay, we just started this project, so you tuned in at a good time. It's still early days, and hopefully we'll take this to a completed game. I usually do these streams on Tuesday evenings, about 8 or 10 p.m. or so in the Eastern Standard Time Zone, once a week. And if you are on Twitch and you subscribe or follow whatever it is here, then you will get notifications when I go online. Sometimes I do surprise streams. I just do things whenever, and you'll get notified of that. If you're in a different time zone, you're watching on my YouTube channel, thank you. You know what to do there. You can subscribe to get notifications when I upload new videos. And you can follow me on the socials. I'm on the Fediverse. I'm on the types.pl server at Agent Ultra. That's right here. Types.pl/web/@Agent Ultra. You can follow me there if you're on the Fediverse. You can also look at the link above. We have a cool Discord server channel for us, and this Discord server has lots of other people who are streaming programming in Haskell and other languages. So check that out. You can hang out there to tell me about your projects, ask any questions you want to ask on the stream, or you thought of later. It's all good. Thank you very much for tuning in. I'm Agent Ultra. May your monads always be free and your types always check. See you next week.